Good morning, everybody. I think nearly everybody is in. Hopefully they are. So good morning, everybody, and you're very, very welcome to this, the AFBI Soil Conference. I'm just going to cover off some of those boring housekeeping rules first of all. So there's no fire drills planned today, so if they do sound, we do need to evacuate, and we'll have to go through the emergency exits out to the front of the hotel into the main car park. And we're told not to leave that assembly point until we're told to do so. Bathrooms are located in the Milford and the Ballygowan foyer there, and this is a non-smoking building, so please do not smoke in the building. Designated smoking space is in the Ballygowan Gardens, and I maybe just ask you to turn your phones onto silent as well. So now that we've that out of the way, may I extend a very warm welcome to you all today. Delighted that there's such a broad spectrum of stakeholders with us, and today is about a focus on soil health in its widest sense. Today's conference really has, started as a very small event, if I'm being honest, on the back of a DAERA-funded soil health project that Lisa Black delivered. But realising that there's a very extensive programme of work in AFBI on soil science and many DAERA-funded projects, the event grew and grew and grew to what we have now presently. So very much want to acknowledge DAERA and their funding for not only the Soil Health Project, but a wide portfolio of soil science-based projects in AFBI, and indeed for the underpinning funding for today as well. So the current soil research programme in AFBI is built, to be fair, on the shoulders of great experts spanning back at least 70 to 80 years. And you'll hopefully get the booklet. We're trying to save as many trees as possible, so it's on a QR code, which should be there. If you wanted to take a photo of that QR code, there is a booklet of today's proceedings, and a little bit of history at the start of that booklet as well, with regards to the many experts that have contributed to the soil research programme in AFBI over the past, as I say, 50, 60, 70 years. And indeed, it's their expertise that has, I would suggest, resulted in the Soil Nutrient Health Scheme, which is a world-leading scheme, as we all know, being rolled out presently. So, say that was the historical team, but I'm delighted that we have equally a very strong team in AFBI with multiple interests in soil science at the minute. So, just to name a few, at the risk of hopefully not leaving anybody out, we've got Alex Higgins there, which very much focuses on the soil-water interactions in conjunction with Rachel Cassidy. Suzanne Higgins, who focuses on soil nutrients and its interactions with air quality. J.R. Roy and Jonathan Holland with a key focus on soil carbon sequestration. We have Lisa Black and David Patterson, who kind of turn it around the other way. Their focus is on plants, but equally the impact of plants on the soil health, as well as Paul Cotney. And then Archie Murchie, our entomologist, again with a focus on insects, but in the soil system. So a great depth and breadth of expertise feeding into what we have in AFBI. So with no further ado, I would like to now introduce our first speaker today, who is Peter Jan Schoen. Peter Jan is the Director of Environmental and Marine Sciences Division in AFBI, where most of the soil science work is undertaken. And Peter Jan is going to take us through the maybe hopefully not so boring topic of the policy and legislative environment that we're working in. And then after Peter Jan, we'll get stuck into the science findings. So Peter Jan, welcome you to the stage.
Good morning. I kind of drew the short straw on this one, being a scientist, having to talk for the entire duration of my talk about policy. No disrespect to my policy colleagues, but not something I'm used to. And I'm not feeling too great, so the excuse if there's any huge lack of enthusiasm throughout, but it is quite a busy space as well. First of all, we'll start off with what soil health is. I can't see this at all. On the from a union, United, thanks very much. United Nations point of view, soil health is defined as the ability of the soil to sustain productivity, diversity, and environmental service in terrestrial ecosystems. So this is one of those concepts that it's similar to sustainability. There's everybody comes up with a different definition or copying somebody else that's close by. So in terms of the EU, it's about chemical, biological, and physical conditions of the soil, and again, providing those ecosystem services. In the UK, in terms of the Environment Agency and DERA's definition are very similar, and it's around the soil's ability to function and sustain plants, animals, and humans as part of the Earth ecosystem. So that's what we're really talking about here, but it's still a lot of controversy sometimes around the definition thereof. So why does this matter? Why does soil health matter? And soil is obviously a fundamental resource that underpins ecological integrity, agricultural productivity, and economic stability. So in terms of agriculture and food security, soil health is essential for the long-term productivity of those industries and providing food, and both in terms of crops and livestock. It provides ecosystem services, numerous ecosystem services, with food production as one, but also in terms of biodiversity, regulate water cycles, contribute to the nutrient cycle, and is vital for the ecosystem balance. It's important factor in terms of climate change mitigation. Soil is a significant carbon sink, and obviously healthy soils can store more carbon. It helps us towards our climate change mitigations. And then in terms of water quality as a filtering and buffering for contaminants, and its protection of our soil resources. In terms of resilience, in terms of weather, healthy soil can cope better with floods and droughts and the likes, and increase our resilience to climate change impacts. So soil health is foundational to environmental sustainability, agricultural productivity, and that global ecological balance. It's also integral to natural processes, human activities, which makes the conservation thereof and the sustainable management thereof absolutely crucial. So in terms of global soil health initiatives, there are quite a few global soil health initiatives. In terms of the UN Sustainable Development Goals, there's a number of the goals that either directly or indirectly relate to soil health. The Food and Agriculture Organization leads on numerous global efforts to enhance soil health and fostering cooperation and promote sustainable soil management. And then there's a 4 per 1,000 initiative that came out of the Paris Climate Change Agreement, where it aims to increase soil carbon content by 0.4% annually. And then there's a World Soil Charter, outlined principles and guidelines for sustainable soil management and protection. And these initiatives play a critical role in raising awareness, sharing knowledge and best practices, encouraging policy action for soil health at both global and local levels. There's also the UN Convention of Combat Desertification, which is obviously not too applicable to us. It's primarily focused on arid regions. There's a Global Soil Biodiversity Initiative, again, linked to that FAO initiative, focusing on understanding of soils and biodiversity. And then there's the International Union of Soil Science, which encourages soil research and education and dissemination of knowledge. So determining which country has the best soil or what's the best example out there is very subjective and depends on various factors, including the country's specific environmental, agricultural, and policy context. However, several countries are recognized for their progressiveness of this. There's no specific country that stands out or you can look at and say that's the best, but there are progressive countries, including the likes of the Netherlands, Germany, Denmark, even Canada and the US is considered in that, and obviously New Zealand as well. So regions and countries have their initiative aligned to these global goals. So moving on to the EU policies tend to focus on a holistic environmental perspective and often addressing soil health in conjunction with water protection, biodiversity conservation, and sustainable agriculture. And this is a common theme running through to the UK as well. There's a huge amount of strategies, but it's all almost like indirectly. There's only a few direct strategies in terms of the EU, in terms of its soil thematic strategy in 2006. And interestingly enough, this also included a proposal to develop a soil framework directive that was established in 2014 and abandoned in 2017. So it's the only directive, EU directive, that's ever been abandoned and withdrawn by national governments. And that's a message in itself on where we are with soil health and the policy landscape. There's a common agricultural policy, obviously not exclusive on soil health, but it promotes good management practices on agricultural practices and ensures sustainable nutrient management and structure and organic matter, which obviously contribute to the whole soil health agenda. There's also a cross-compliance mechanism. It requires farmers, in terms of the subsidies, to maintain land agriculture and a good agricultural and environmental condition. Water Framework Directive, again, it's around pollution and nutrient management and to improve our water quality, and thus this involves measures to protect soils and improve soils. There's the Nitrate Directive, which is a very similar objective in terms of water quality and good practices around that leads to improved soil management practices. There's the Environmental Impact Directive. It requires assessment of environmental impact on certain public and private projects, including the impact on soil. There's the Habitat Directive, which is obviously indirectly and leads to focusing on protecting biodiversity, including soil ecosystems. EU biodiversity strategy, again, around that biodiversity agenda of soil health and ecosystems and the restoration thereof. There's the pesticide directive, indirectly benefiting soil health. There's the landfill directive around waste, and again, an indirect influence on soil contamination and land use. Renewable energy directive, farm to fork strategy, which is part of the European Green Deal, and reduces the risk of chemical pesticide. So the EU policies tend to focus on this holistic perspective, as I said. There's other, this is not an extensive list, there's loads of these indirect policies, and I'm not was not intending to try to give the definitive list, but more or less paint a picture around getting to the conclusions. For example, there's also the land use and land use change and forestry, LULUCF regulations, which is also linked to it. So in terms of future development, the EU is actually very proactive at the minute. They have a proposal on soil monitoring and resilience directive. And the key of this directive, it's actually a published proposal at this point in time, and it aims to deliver significant environmental benefits to improve soil health with the aim of getting to healthy and managed sustainable soils in the EU by 2050. And the key development here, which is an important one and missing from most of the other things, is that it includes specific indicators on the performance and detailed criteria of soil health. Currently, this includes things like salinization, soil erosion, loss of organic carbon, phosphorus content, water holding capacity, but it has no criteria at the moment for nitrogen, pH, loss of soil biodiversity, so it only goes kind of halfway to addressing in totality. So in terms of the UK then, there's several strategies, policies and pieces of legislation that significantly influence soil health. And again, it's around recognition of soil as important within the agricultural, environment and climate change agenda. Again, a significant amount of things here, very similar themes to the EU in terms of the Agricultural Act, which is obviously the replacement for the EU CAP, the Environmental Land Management Scheme, which is the main delivering mechanism for sustainable soil management in the UK, but it's still relatively weak. And it's around those EU subsidy schemes and the replacement thereof. There's the environmental plan, 25-year plan, and this sets our goal to manage land sustainably and improve soil structure and fertility by 2030. There's the Environmental Act, which is still currently going through, and this is also, some of these obviously also applicable to Northern Ireland. For example, the Environmental Act, but there's very little specific reference to soil health in the Environmental Act. There's the Country Stewardship Scheme, which encourages farmers to implement practices to enhance environment and improve soil health. There's a soil strategy for England, which is part of the 25-year plan. So it's linked to that management of sustainable management by 2030. There's farming rules for water, again linked to the water quality and what you're doing on lands affecting the water. There's the Climate Change Act, obviously not specifically on soil health, but it's got the greenhouse gas objective and improving soil health in terms of to improve soil carbon storage. There's the nitrate pollution prevention regulations, again that link between nitrate and water quality and indirectly get to improve soil health management. There's the woodland carbon code and the peatland code, which again is very much linked to improving those environments that's indirectly leading to improved soil carbon sequestration. And these strategy and legislation matters reflect an integrated approach to managing the soil health in the UK, linking it with the wider environmental objective, such as biodiversity protection and water quality and climate change mitigation. So in terms of current developments, there's under these various legislation, there's a need for environmental improvement plans under the Environment Act. This also applies to Northern Ireland, but in England they actually set targets for 40% of agricultural soil to be sustainable managed by 2028, and this to increase by 60% by 2030. But there's no definition of what is meant by sustainable management or any indicators around it. There's also the land use framework. It's about optimizing multiple benefits from our land. And all the regions in the UK is currently going through the process. Scotland's the only one that actually has something in place on that already. And then there's the development, they're still developing matrices for their soil health action plan, which is linked to the soil strategy for England. So just obviously, like a lot of those things are linked through to Northern Ireland, but I just thought I'm highlighting something specific for Northern Ireland. And again, those policies, you'll see a common theme there, not directly on soil health, but through the reflecting, putting it into context of environment, agriculture, and land management. And so in Northern Ireland, we have the environmental farming schemes, again, encouraging good practice, which benefit the environment, including soil health. We have our own Climate Change Act, which have similar, benefits to the overall UK one. The Nutrient Action Plan is very similar to Nutrient Management Plan in the EU and UK in general. And then we have very ambitious draft policies at the minute in terms of green growth, environment, and also the future agricultural policy, which link all these things together in terms of environmental sustainability, air and water quality, soil health, and biodiversity. The draft environment strategy is actually setting targets or proposing to set targets to have efficient use of natural resources, including water and soil, by 2031. Obviously, a big part thereof is the current soil nutrient health scheme, which we'll hear about later, and which is currently seen by others, especially in the UK, as something where they need to get to, and the guidelines for good agricultural practices and soil management, and the proposals to link it to those single farm payments to encourage things. So environmental improvement and climate change action plans is also under development in Northern Ireland. So soil health challenges in terms of policy. This is the second last slide. In terms of legislative framework and soil health is very disjointed in the UK. Similar in the EU, but they're trying to get it through with this new proposal now to bring it together. So there's no standalone comprehensive policy specifically for soil health. And that's one of our biggest problems. And again, the other part of it, there's a lot of ambitions in these policies and legislations, but we have no specific standalone targets and indicators for soil health. It's like, what is our measure of success and what are we aiming to get to that are quantifiable, similar to what we have, for example, for water quality and air quality, greenhouse gas emissions. So, when you start reading about things, people often comment that soil health is the Cinderella of environmental issues. It's something that's been neglected by government and stakeholders when it comes to investment in terms of regulatory protection, monitoring, education. And one of the reasons behind that is like, if you look at the air and water quality, there was threats around fines through EU directives. And that provides the impetus for policy intervention and, most importantly, investment into it. So I think there's something missing there, but so the NGOs are very much on the page that these things are very ambitious, but they are not doesn't have any clout around it or any strong direction of where it needs to go. So it's almost like a wasted opportunity. And this approach is reflective of the complex nature of soil ecosystem, our lack of understanding of the baseline of soil health, and diverse range of factors influencing soil quality. And this is common across all regions, linking to funding, climate change, and policy implementation, as I highlighted. So in conclusion then, soil health and sustainable management soil indicators need to be developed, taking spatial heterogeneity, multifunctionality, and land use scenarios into account. Advancement in science understanding and development of new soil management techniques, which we'll hear about some of that for the rest of the day. And then there's that variable, specific implementation of the details of policy legislation is very varied across the UK. And that's where, as my earlier comment says, is that NGO then make comments like it's ambitious potential, but weak accountability. And then one of the key things we always talk about, especially in these initiatives, is that behavioral change needs to happen. And achieving behavioral change only happens through legislation, the enforcement of those legislations. Some of these things has already been indicated that there will be no legislation around it. And the only way around it is then to have public awareness and education initiatives, which also takes a huge amount of effort in terms of educating farmers, landowners, and the general public about the importance of soil health and sustainable land management practices. So it's a very complex and disjointed policy framework at this point in time, but it's such a crucial aspect, and everything's depending on it, land use optimization. The baseline is soil properties and soil health to optimize anything. But I'll leave it at that.
Thank you. We do have a roving mic. Sorry, Peter-Jan, don't skip you. We do have a roving mic if anybody has any questions for Peter-Jan. Patrick?
Peter, you didn't mention the EU Soil Mission Board, who currently have a call out for a huge and heavily funded program on soil health across EU, and hopefully that'll be coming on stream from early next year. Mm-hmm. And I think that there is a huge focus coming from that. Obviously, it doesn't affect us, but it should influence the way that we look at soil health, and I think part of the idea is to create or develop some of these indicators mm-hmm. that you have highlighted as the priority required here. It's really more a point of information than it is.
Yeah. No, as I said at the start, there's definitely not a definitive list. The EU soil missions is one. There's a lot of initiatives in the UK as well to develop indicators. And that's the difficulty here as well, is everybody coming up with their own indicators, and that's the big challenge with soil health legislation policies in particular.
Any other questions, or Dave? Yeah. Carolyn's coming with a wee mic.
Just another point of clarification in terms of targets and where we're aiming for. The Northern Ireland Climate Change Act has a requirement for us to set a soil quality target within the first carbon action plan. So that in itself will hopefully drive policy development. So just to mm-hmm. add that in as well in terms of future targets that will drive policy on soil health.
But it's around climate change aims, so it's carbon focused.
Yeah, but the way it's worded, I think there's a bit of wiggle room. We're looking at it to see, what it means in practice. But it was included in there as part of the assembly process as an amendment to the Act. So mm-hmm. it's the first time there's been a statutory requirement around soil quality.
Thanks, Dave.
Okay, so I think we've opened up a debate, Peter-Jan, which we'll maybe pick up in the panel discussion around. There seems to be a really rich legislative and strategy environment, which indirectly soil needs to play a role to deliver a lot of those goals, but actually the debate is, posed, do we need soil indicators? People say yes, but maybe they're already there. So that's for later, Dave. You can pick that up later and think about that between now and 3 o'clock, if that's okay. So we'll move on now to hear some of the work that's underway under the Soil Nutrient Health Scheme. I'm delighted to invite Rachel Cassidy, who is the lady in charge and leading the way in the massive soil scheme. And well done to Rachel for all her excellent work so far. So we're really looking forward now, Rachel, to hearing what the latest is. Thank you.
Okay, thanks, Elizabeth. I have to decide whether to put on my glasses and not see it, or put on or leave them off and see the screen. So you're all fairly hazy, which is good. So as Elizabeth said, I'm the one they push out front when talking needs to be done about the Soil Nutrient Health Scheme, which you may have heard about, I hope, by now. I suppose it is the most comprehensive regional soil sampling and analysis scheme that's ever been undertaken, as far as we're aware, with a view to providing every farmer with a level playing field on which to start soil nutrient management. They'll get full sample analysis, carbon estimates, and with that, they can optimise, I'm going to have to put on my glasses because I can't see, crop nutrient applications, assess on-farm carbon stocks, and ultimately build farm resilience. And there is a strong emphasis within the scheme on building and delivering environmental benefits as part of that efficiency and and nutrient management planning. And I can't go any further without acknowledging that I am one of a very large team. Particularly want to highlight Alex Higgins and Colleen Ward and AFBI who helped manage the scheme. The DERA team led by Stephen Archer who run the scheme and pay for it, and our colleagues in Caffrey, Avian McMullen and Emma who have helped deliver the training that's associated with it. So it's a very large team. It's impossible to name everyone, and additionally our contractors in RPS and NRM. So the scheme is open to all farmers in Northern Ireland who are actively farming. It's free. Farmers only have to register. From then, all the sampling is done for them, and the results come along later. Ultimately, by 2026, we aim to have sampled 700,000 fields by geographic area across Northern Ireland. We're just completing Zone 1, you can see in yellow in the south east, and moving now, we started yesterday sampling in Zone 2, where there are 190,000 fields registered to be completed by end of February next year. There's a really strong scientific basis to the Soil Nutrient Health Scheme. It's building on decades of AFBI agri-environmental research, soil research, work by John Bailey, catchment science, agronomy, biogeochemistry and social sciences. It's been done in partnership with national and international universities and institutes. The origins, I suppose, go back to 2016 when DERA commissioned the expert working group to produce the Sustainable Agri-Land Management Strategy for Northern Ireland, and some of those people are here today that were involved in that. And it laid out clearly at the end a list of objectives from Northern Ireland, among which soil sampling was highlighted, and that was because at the time it was estimated that fewer than 10% of farmers actively soil sampled and used that in the nutrient management. We followed that. DERA funded the soil pilots in 2017-18 and 18-19, and that sampled in catchment and broadly across NI to get a feeling for the evidence base of a need for a scheme such as this. And it did back that up. There were a very high proportion of soil sampled with pH requirements, excess phosphorus and so on. Alongside that is AFBI research running in our catchment platforms, particularly Upper Bann, where we look at the links between agricultural practice on farms, climate, landscape factors, soil, and how that impacts water quality. And on the basis of that, we drew some pretty strong relationships between the proportion of catchments that are above optimum for soil test phosphorus and the water quality concentrations in rivers. We also highlighted using runoff risk maps that there are very sensitive areas within catchments prone to losses that are delivering a lot of the annual load of nutrients to our rivers. So building on that, and that was work with Ulster, we've also undertaken behavioural change research led by Leeds, which evaluated farmers' participation in the pilots, assessed the benefits they got out of it, which were improved yields, improved awareness of the environmental impact, and ultimately combining all of that with the evidence base for the Soil Nutrient Health Scheme. And I think DERA have taken a very brave step in investing in an area which I've heard referred to as just that brown stuff. So, it's brought soil front and centre again in our thinking and our research and highlighted its importance. So what exactly do farmers receive? Well, it's a Northern Ireland baseline. So every farmer that registered will have their soil sampled. RPS group are the contractors. They'll contact them in advance. They'll go out. The samplers are trained. They follow a strict protocol. They have GPS-enabled devices with pre-populated W tracks that they walk in each field. They take 25 and above cores per field. Each bag has a QR code, and that QR code tracks it from the field to the van, to the depot, to the lorry, to the boat, to NRM K-Woods in England, who are the analysis contractor. And they're accredited, and the samples are all analysed for P, potassium, pH, magnesium, calcium, sulfate, and loss in ignition. And samples are taken to 7.5 centimetres depth in grassland and 15 in arable. Farmers 4 to 6 weeks later receive the results in the post as tabular prints from NRM directly. This is followed by the DERA online system, which generates the maps for each farm and presents the data, as you can see it there, maps of pH lime requirement, phosphorus. They're all colour-coded to make it as easy as possible to visualise the results, see where there's maybe a need to add nutrient. Fields are coded yellow, green if they're optimum for that last crop, next crop that the farmer's provided, and red if they're in excess. And this is provided for all nutrients. The farmers can go online, and we hope they will go online and view that. They can look through their maps, view the whole farm, turn on and off different layers, and it really is, very helpful in terms of seeing your whole farm at once and planning. The other aspect of the delivery beyond the nutrient status are runoff risk maps, and this is an attempt to try and provide farmers with information on how they can mitigate the impact on water quality. We model areas of high risk overland flow using LiDAR digital elevation models. I'll show you one of those in a moment. But in Northern Ireland, because of the preponderance of impermeable soil, steep slopes and no shortage of rainfall, these red and yellow areas are where the water tends to run during rain. It picks up any available nutrients, and that's the quick delivery we get into our systems. The time series there that you can see is water quality from one of our monitoring stations. So you can see rainfall events happened about the 4th and into the 5th of September. There's 2 peaks as water levels in the river increase. And with that, you can see turbidity, the brown filled graph on top, increases very rapidly, and the phosphorus concentrations go up too. So single events like that can account. Last weekend, we had maybe 10% of the entire annual nutrient load lost in some of our upper band catchments just through that storm Babette. So it's a very dynamic and very important route and for loads entering the system, and it's important that we highlight these as sites for mitigation. So this is the LiDAR data that's used to generate those models. It's flown by plane, 16 points per metre. We're still part way through Northern Ireland as a whole, but we take the bare earth model. The GIS team in AFBI simulate overland flow on the bare earth model. We also then take in soil permeability factors to weight it so that areas of very high impermeability generate most runoff. And you get a topographic map, as you can see there. So that's just shown the top 5% runoff risk for this area. Runoff's coded from where it's likely to where it's most likely. We also identify depressions where water lies. So these are when you drive past fields and you can see a sort of pond shortly after rainfall. These are areas where water's infiltrating over time. So these are uploaded to the system, and this is the maps that farmers see. So you can see along that area of river, there's a lot of runoff risk. These may be marginal parts of the farm that are saturated for most of the year. The idea is that farmers think about that and think is it worth trying to bring that into intensive reduction, or are there other schemes? Could you farm it for carbon or farm it for nature? When you're applying slurry, we advise to not, you maybe leave areas with a very high risk until the ground is dried out, later in the season, and the grass is able to take up the nutrients. So you minimise the risk of taking the most valuable thing you have and losing it to water. So we have a focus on carbon within the scheme. Both soil carbon, as Elizabeth mentioned, J.R. Rao is leading the project team on that with Ulster University and Queen's radiocarbon dating labs. And they are looking at soil carbon. It will be a modelled estimate for each farm based on the loss and ignition values measured, or the soil organic matter content in the soil samples, and that's validated and verified by a set of extensive tests being undertaken at sites across NI, both for changes in land use and soil type. In addition, above ground biomass is being considered in this, and this is not included in inventories at the moment. The LiDAR scans allow us to extract the vegetation, so you can see the point cloud of the trees there that Alex Higgins is working on with Joe Hornsey. And you extract that, you can calculate the volume, you can apportion a carbon content to that, and you can get an estimate overall for the farm. And it's a baseline, it's a starting point on which to build. And finally, the final important but not least thing that farmers get in that is once you have the results, you need to know what to do with them. and CAFRE have put together a very comprehensive nutrient management training plan for all farmers who participate in the scheme should participate in this. It's been delivered online in 2 phases that lead you from basic understanding of what the results mean through to develop a nutrient management plan, and they've also provided for this to be delivered by face-to-face and on webinar formats as well. So there's a team here today who can talk about that to any of you if you're interested in more information. The crop nutrient calculator, which is CAFRE's main tool for farm nutrient planning, is now pre-populated with SNHS results. So instead of having to type it all in, it's all already there. So it makes the process of nutrient planning a lot easier than it used to be. So that's the baseline, that's what farmers receive, that's the objective, to provide them with this valuable source that they can use to plan and manage going forward. Underpinning that, AFBI have a big research project running alongside this to make sure that the scientific basis of what we're providing to farmers is as strong as it possibly can be, and that's primarily with Ulster University and with the University of Leeds, who've been partners in this since the pilots. One key thing, I suppose Suzanne's coming up next, is developing a soil P test that's more appropriate for basalt soils. We know that Olsen P extraction is not great when it's soils with a very high iron or aluminium content, so it's underestimating the amount of agronomically accessible P that's in the soil. That needs to change, so by the time we get to Antrim in year 4, there'll be a test specifically for that. There's also the water research. We need to understand more the link between soil and water and how one affects the other, and look at ways of mitigating that. We're working to develop and validate the runoff risk maps further. We're looking at how you can redistribute nutrients, how we can set carrying capacities for different catchments as to how much load of nutrients they can safely accept. There's research, as I said, on the carbon and above ground biomass development, and leads throughout the entire project are engaging with the baselines and the zones as we proceed. They're undertaking behavioural change research to assess what impact participation in the scheme is having, what additional advice is required, how farmers' environmental consciousness is changed through participation in the scheme. We have mobile monitoring units which were taken out as part of the scheme, and the idea is to make real live water quality data, like you showed you earlier, accessible to the public and to farmers, so that they can make that connection a bit more easily than if it's just a status update for a catchment or 1 point annually or monthly. So I suppose some people want to know how we're getting on and what the results are. To date, we've still about 9,000 fields in Zone 1 to complete, because we had early slurry applications in spring which affected it. We've had 292 additional businesses come in the summer recruitment, so we're now at 95% overall participation in Zone 1. And to date, we have analyses for 132,775 fields. Some of those are averages where the fields are very large and there were multiple samples taken. So I'll show you first pH as the critical factor in nutrient management. If the pH isn't right, even if the nutrients are there in the correct proportions, the crop will not achieve what it could otherwise achieve in terms of yields. So overall, in Zone 1, the percentage of fields that received a crop-based lime recommendation is 58%. So that excludes any fields that had an environmental designation. They do not receive a lime recommendation. We do know, though, that there are some individual peaty and organic soils that the farmer knows about and we don't, that will have to be, and it's why when farmers get this information, they need to take it and manage specifically for their own land and identify those peaty fields and bring down the lime recommendations associated with it. So yeah, there's not much variation across the map. Uplands obviously will be lower pH. The Ards Peninsula does quite well in terms of being above pH 6. I think that's down to the high arable farming density in that area. And there probably are rainfall factors. We found in the west, in the Coldbrook, that 80% of fields had a pH recommendation compared to 40-something in Upper Bann, and rainfall leaches ions out of soil, so it's there's probable rainfall effects, and ours is particularly dry. Phosphorus, this probably is the one a lot of people are asking about, and that's the map on the left. Overall, of the fields we've tested, 45% are at index 3 or higher, so that's above the agronomic optimum. It's exactly the same number as we found in the Upper Bann catchment pilot, so we're not surprised by this. It recognises that we have a pea surplus in Northern Ireland. We've 12.5 kilos pea per hectare balance, and that there's a lot of work to be done to reduce that balance by reducing our dependence on concentrate, feed and fertiliser, and the key to that is going to be efficiency on farm and supplying the nutrients the crop needs, and Suzanne will talk a bit more about that in the next presentation. Potassium, as the other key nutrient, 73% of the fields were at index 2+ or higher. That is, we suspect, mainly just down to the amount of potassium in organic manures which are being put onto land, and also its presence in a lot of the compound fertilisers. And I'm not presenting here sulphate or magnesium, I'll just give a verbal update on those. 99.9% of fields are at or above optimum for magnesium. It's mainly the geology, it's especially high at the edge of the basalts, and it's down just purely to the parent material for the soil. Sulphate, 96.8% of fields are at or above optimum, so farmers have clearly heeded the advice about putting on sulphate along with nitrogen for early silage crops, and I suppose maybe need to use the results to identify if so much is needed in future, because it costs. We've split out the differences by sector. Again, due to time, I'm only going to show you phosphorus. These are the area-weighted farm averages. So for each farm, it's averaged, but it weights it by the area of the fields to be as fair and representative a measurement as possible. The box whisker plot you see on the right is split out by the sectors, the main sectors. I'm not showing poultry or pigs because there's only 4 and 10 farms declared in those allocations, and it's not representative to show that. These, though, are the full distribution. So this is what farmers have classified their farms as. So mixed livestock could also have poultry, it could have some pigs in it. It's variable, and we don't at the moment have a way of tying that down more precisely. The one I want, I suppose there's 2 things to point out. First, the huge variation in the distributions. That shows from the minimum beef rearing farm is operating at less than index 1, nearly index 0, and at the other extreme end, there's one operating at a farm average of index 6, which is incredibly excessive levels of phosphorus. And everything in between. The blue box, though, was 50%, and the whiskers are 90% of the distribution. And the one that I just want to highlight is dairy. The median for all of them is in or around the upper level of index 2+ into index 3, arable a bit higher, but dairy has by far the narrowest distribution. There's more homogeneity among dairy farms than any other sector. They're only slightly above the index 2+ threshold in terms of the median, and 90% of the farms are between index 1 and index 3. And there's only one farm that goes up as high as index 5. So I think, that is evidence of management on those farms. Dairy farms are perhaps more aware of grass growth and the need to maintain that for milk production. And we think that this reflects just a more involved engagement with their soil on those farms. So just plotting that geographically, for a minute, the thing I want to point out is that, so these are farm averages and a bit blurred, so we're not identifying anybody. But I think when you plot it like this, you see how much orange there is on the map, and that's index 3. So the vast majority of farms that are above optimum are in index 3. So it suggests that they're potentially modest changes in management could help bring those farms down to index 2+ or below. So I think there's some sign of hope in that. The growth success are very, very few and far between. And I suppose then within farms, again, these are big global pictures for Zone 1, but the importance of farmers taking the results and managing for their individual farms and fields is really important. The graph on the bottom left comes from the soil pilots, where we looked at the distance from the farmyard to different fields on the farm, and saw clearly that the fields that are closest to the farmyard tend to get a bit more traffic with the spreader, perhaps. So they're sitting, with index 3 in general, close to the farm, and as you move further away. So distance factors are a big thing. So I suppose overall the aim of this scheme is, the big picture is good to look at, but ultimately the results are for farmers. We want farmers to take the results. We want them to use the results to make the most out of the most important resource they have on the farm, which is their soil. We want them to take part in the CAFRE training, understand what the results mean, and put it into action. And by saving money and increasing grass crop production, hopefully that efficiency will come through to the environment in terms of less potential loss. So I'm ending just with another flash up on the CAFRE training to highlight that we really need to try and encourage our farmers to participate in this. And the CAFRE team are out in the foyer if anyone wants to speak to them. So I'll leave it there.
Thank you very much, Rachel. You just whet our appetite there at the end, didn't you, with a few of those graphs, which was really good to see those results starting to come out of Zone 1. Any questions for Rachel? Yes, please. I think it's Carolyn's coming with the mic.
Just wondering, when the programme has finished, will all the data be available publicly on open data or anything?
No, the soil results will only be available to the farmers after they can use them for research, and they can be used generally for policy development, so they won't be ever, the soil nutrient measurements won't ever be public. Okay. The LiDAR data ultimately will be available through the DERA system.
Will the research papers be open access?
Yes,
okay.
All of them in provision in the budget that all research coming out of this will be published open access and fully available. We are going to summarise catchment and higher level, but we can't ever get it down to a granularity where you can see a farm.
Oh, no, I wasn't thinking. I was thinking more along the lines of the Talis Rural Soil Survey that happened around 2004, 2006, where that was open, currently available for people to do analysis on. Is there something similar going to happen here, but maybe not?
I don't think not at sample level or farm level, because it is primarily just for farmers, and it's nutrients more than soil technical characteristics and that. But anything that is coming through the research will be made.
Yeah.
Cool, thank you.
Yeah. You can imagine there's a lot of sensitivities around the farmer data. Any other questions? Yes?
Will there be is there any type of similar research regarding microorganisms in the soil, regarding fungus or bacterial activity in the soil, and how that affects plants' ability to take up the nutrients?
Well, I think there's talks later today on that, but also in the soil carbon research work package, JRO, and the team from Ulster University, Nigel Ternan, over there is looking at enzyme activity and the microbiome. So there's work ongoing at that.
You'll hear a little bit more about the more biological pieces of the soil health story later on. Yeah. Claire?
Hi, thank you. You talk about the data being a baseline. Are there plans to rerun the tests in a number of years, or is there any intention to do so, or is it just getting through this?
Well, for me, it's getting through this in one piece. But you'd have to ask DERA, I think. You would hope at some scale there would be room to, see what's changed. We want this scheme to have impact. we want farmers to engage with it and, you know, show that change can be made voluntarily through, you know, direct action on farms by the farming community. So I think I would like to see a resurvey, but I suppose it would be down to DERA and the, you know, the budget availability.
And there was somebody, Gillian?
The 25 samples that you mentioned at the beginning, it's the same as a standard tipulid larvae survey. I wondered if tipulids or earthworms are looked at from those samples.
Well, I mean, if they are, they'll be chopped up quite a bit.
Okay.
Because the augers narrow it, so they're just walking through the field and core in 7.5 centimetres, and that's all mashed into one bag. So they're probably bits of earthworms, but not whole ones. I suppose the soil carbon research that's going on is looking at earthworms as part of the metrics of soil health that they're collecting within fields across. So that does focus, and there's a talk later, I think, on earthworms.
Yes, Archie's going to be talking on Archie. So, gentleman at the back, please, first, and then Alan, and then Cormac.
Just coming from a farmer's perspective, I've heard a number of farmers very concerned about the information. Obviously, we know data protection is going to be, you know, it's for the farmers, this information, but their concern is, you know, say for example, you have soils and they're very high in nutrient. Do you foresee this becoming an issue whereby they are going to be told in the future through policy that you can no longer use the farm nutrient that you have because these fields that you have are, you're oversupplied for what crop you intend to grow?
I think that's a question for the policy makers. I think from a scientific perspective, it's very hard to tell if even in a field at index 5 today, if that's due to your actions last year or, you know, nutrient that was added 10, 20 years ago that brought it up to that level. So there's levels of complexity that would have to be looked at. But there's one thing for definite is there'll be no use of this for enforcement. And I suppose how it ultimately comes through to policy would be something I'd address to the policy makers that are here today.
Yeah, the key is this is to help farmers manage their soils for a profitability and environmental sustainability agenda.
Yeah, and
that's the key.
That's the primary aim of this. Nothing else. There's no conspiracy. Where we have in some of our catchment focus catchments where farmers have got these results in 2016, looked at them, done nutrient management planning, they are reporting like big savings on fertiliser, better grass growth by getting their nutrition in order, and Suzanne's talk will cover that a bit more. And you know, it's making those results work for the farmer. That's the primary aim of this.
And you've seen improved water quality in the upper band as a result too, is that right?
Well, yeah, in two, it's small, it's two focus catchments we've worked on. We saw improvements between 2016 and 2020. Interestingly, during COVID, as our engagement and advice within the catchments waned a bit, in one of those catchments we have now seen a bit of an increase in both the soil nutrient P levels and in the concentration. So there is work ongoing to look at the how advice plays into this. Yeah. But it can, I am confident, deliver improvements quite quickly.
Alan?
Alan Chambers, arable farmer.
On the yards?
Quick, hide the maps.
Were I a grassland farmer and had received my results from the Soil Nutrient Health Scheme, and I've been told that my pHs were 5.8 and my phosphate levels were 3s and 4s. Where are the results and the trial results to back up and convince farmers that they should they should correct their pH and they should not apply phosphates? And secondly, why in the island of Ireland do we have two different sets of recommendations as to what pH we should target to maximise our yields? I cannot understand that. I need an answer. Thank you.
Well, I probably can't give an answer on the pH one because I have wondered about it myself, and probably Suzanne, who is on the RB209 group. I mean, the difference is that Northern Ireland follows the RB209 recommendations, and that sets a target pH of 6.2. In the Republic, it's 6.3. I don't know is the answer to that. And I think there is...
Sorry, in response to that, how can farmers be expected to follow recommendations
I don't think they're in disagreement. If you can hit a target index of 6.2 to 6.3, I'm going to leave that to Suzanne to comment on, I think. But I mean, the consensus is agreed on both sides that you need to be above pH 6, and there is research done which shows plant response as pH levels change, both in how much of the phosphorus and all the other nutrients they take up. So this might be in your...
I think it's fair to say it is one that we do need a bottom out, to be fair as well. You know, I think we'll take that.
I mean, for pH, the thing I've thought about is possibly the higher rainfall in Ireland island means that there's higher rates of leaching, so setting the pH a bit higher gives you longer for it to fall back down. But I don't know, this is Suzanne's area, I'm speculating. And I think she'll also present you some of the research that shows that there is a good, strong evidence base behind the nutrients.
Cormac, you're the last question, because we do need to move on. And
I was just wondering, in terms of the soil results, was there any difference between land owned and land rented? You know, we're often told that Conacre land is often neglected.
We haven't looked at that yet, but we will.
Good question. Yeah.
I mean, there is anecdotal evidence that Conacre land, perhaps, or short-term rental land isn't, you know, as actively managed as land that someone owns that is theirs to protect. So, but it is something we are definitely going to look at, and it's part of the behavioural research as well that Leeds are doing. We'll split out, you know, farms that are mainly Conacre and see if there's any difference in attitudes with that. So it's on our agenda.
One final question. Is there a positive in your maps for phosphorus that there's quite a proportion were yellow, which was index 0 and 1?
Well, only in the uplands. Mainly.
Okay.
I mean, the more heartening thing for me was when you looked at farms on average, that you know, the very excessive levels come down.
Sure.
So there's a sign that you can redistribute nutrient within the farm and maybe in more intensive management bring the whole farm down. So I suppose that's my key positive, and also that dairy farms sometimes don't deserve the stick they get. So.
Very good. We'll not know who to pass that stick on to. But thank you very much, Rachel. Really fascinating, and thanks for an insight into Zone 1. So I'm glad we made a mistake in the timings for the session, because we are running behind, but I think it's all good stuff. So next up is Suzanne Higgins, who is her expertise is in soil fertility, soil nutrient management and precision agriculture, and today we'll focus in on that soil nutrient management agenda to optimise production and minimise environmental impacts. And just for anybody, as Suzanne's making her way up, the Wi-Fi code is capital G, in GUEST, capital G, G-U-E-S-T 2023, okay? Thank you, Suzanne.
Good morning, everyone. I'm going to talk specifically about the wider soil nutrient management programme in AFBI and links with soil nutrient management and soil health. Okay, so soil nutrient management is integral to soil health. So how we manage soils can promote soil health, it can maintain soil health, or it can be recovered through these sustainable soil management practices. And it's estimated that around 70% of soils across Europe are currently classed as unhealthy. So this is a big focus across Europe currently, that we really need to look at the health of our soils and try and improve soil health overall. So why is soil health important? So what we mean by soil health, it's the performance or functioning of a soil as a dynamic living resource. Okay, so a soil is a living ecosystem. 1 teaspoon of soil contains more organisms than there are people on Earth. So this is really fascinating. Soil is such a living ecosystem. We really need to protect our soils. And so there are a number of indicators and thresholds defining soil health, and these are all site-specific, and they're sensitive to how we are managing those soils. So the specific challenges we have in Northern Ireland, so we're a livestock-dominated industry, so what we're trying to do is try and balance that production with the environment. So in Northern Ireland, we have a lot of problems with nutrient emissions to the air, such as ammonia and greenhouse gases. We also have the problems with nutrients getting into our waterways. So what we're trying to do is balance the production with the environment. So we want to sustain or enhance our soil fertility, sustain production and build soil resilience while minimising nutrient losses to the environment. So soil health is really important because if our soil is healthy, it has ability to adapt to a changing environment. So this means periods of flooding. If your soil is healthy, your soil will recover from a period of flooding, it'll bounce back. Similarly, if there's a period of drought, if your soil is healthy, it can withstand the pressures and the challenges, the stresses from a period of drought, and it'll bounce back quickly. But if your soil is unhealthy, then it means it can't, it has less ability to be resilient against those stresses. So going forward, and particularly with potential climate change, we really need to make sure our soils are as healthy as they can be, so they can withstand any particular environmental stresses going forward. So in AFBI, we have a number of levels of research in terms of soil health. We have that regional scale research through the Soil Nutrient Health Scheme. We also have focused catchment research. We have specific farm level research, and we go down to the field scale as well. So for example, our farm scale studies, we would look specifically at farm type. So we look at arable farms, grassland farms. We look at farm intensity, so the more intensive, for example, intensive dairy farms or beef farms to the more extensive systems. And we also distinguish between soil type. So we have a huge variation in our soil type across Northern Ireland. We focus mainly on the main plant available nutrients, main plant nutrients, nitrogen, phosphorus, potassium, sulphur, and of course pH, but we also look at micronutrients. And now going forward, we're focusing down into more of a sub-field scale research programme, trying to get that, improve that precision of management of nutrients at a sub-field scale. So first of all, our regional scale research, this is what Rachel was focusing on in the Soil Nutrient Health Scheme. So at the regional scale, you can see the influence of wider soil forming factors coming through. So your landscape factors such as topography comes through, the effect of geology and the effect of climate. So your management sits on top of these factors. So at a regional scale, a Northern Ireland scale, you can see the effects of upland areas, mountainous areas, and where our distribution of peatland soils, upland soils, and then our lowland soils. There are differences between soils in relation to topography. There's a strong geological influence in our soil properties across Northern Ireland, and also climate's important. So this is a map of Zone 1, and you can see there what we find really interesting in the Zone 1 results was this band of the red colour. This is soil magnesium. You can see the red colour there on the northern edge of Zone 1, and that is the magnesium in the soil, and that is related to the basalt parent material that is coming through in that northern edge of Zone 1. Okay, so basalt soils are really important for us in Northern Ireland. You can see on the map on the left there a huge area of orange. So a third of Northern Ireland is covered by these basalt soils. So your soil forms from an underlying rock parent material, and the soil takes on a lot of the characteristics of that underlying parent material. So basalt soils have particular unique properties. They're rich in minerals, particularly iron, aluminium, magnesium. So you could see in that magnesium map there, the higher magnesium's coming through where there's a basalt parent material. They're very high in nickel, copper, a lot of trace elements. They're a distinctive red-brown colour, and they have very unusual properties. So we know that from previous research historically that phosphorus is held differently in basalt soils. We know it's held tightly by the iron and aluminium in these soils. So in the Soil Nutrient Health Scheme, we have a specific work package of research, particularly on the basalt soils. We have 8 sites, farm sites across the lower and upper basalts. We're looking how phosphorus is held in these soils. We're looking at the way we test the phosphorus in the soils and the fertiliser recommendations farmers are getting. Because we know that the Olsen P test, which is the test we use to measure phosphorus, is potentially underestimating the amount of phosphorus in these soils. So as a result, farmers are maybe told to apply phosphorus possibly above what is needed for agronomic production. So this is a programme of research we're doing for the first 3 years. We're into our second year of it now. I've just finished our second year, and we will hopefully have this bit of research completed by 2025-26, whenever Zone 4 is sampled in the Soil Nutrient Health Scheme. So this area of basalt, this is all of Zone 4. So this will be the final zone to be sampled in the Soil Nutrient Health Scheme. And these soils, you will know, Giant's Causeway, you'll know the basalt soils are very distinctive and basalt rock because of our Giant's Causeway, and a lot of people will know the distinctive properties of that rock. So finally, climate. So in Northern Ireland, our soil and our soil health is very much influenced by climate. So we have a very high rainfall regime. We're getting 1,000 to 2,000 millimetres of rainfall annually, particularly in the west. So the west, Fermanagh, it is Zone 2, so we're going to sample Zone 2 now. And we're going to be interested to see the influence of the high rainfall on these soils. So in the dark orange there, these are soils which can be saturated or above field capacity for over 250 days of the year. So this has huge implications for our soil health. So when soils are very wet like this, it affects the chemical properties of the soil, the physical and the biological. So in terms of the chemical properties, nutrients, when soils are very wet, nutrients run through the soils a lot easier. We also have that problem with surface runoff of nutrients. In terms of biology, very wet soils have less oxygen in them. So there are a lot of microbes in the soil which are more adapted to anaerobic conditions. So this affects the biological condition, biological health of our soils because of the number of days our soils are wet through the year. And then the physical properties are also affected because the soils are that wet. We have to house our animals for 6 months of the year. They're very vulnerable to compaction. So the climate, the geology, and the topography, when you're looking at a wider sampling regime across Northern Ireland, these underlying factors become even more important. And it's very interesting for soil scientists because normally we're looking at a farm scale or a field scale where the soil properties are very much influenced by management. When you're looking at a wider scheme like this, geology, landscape and climate become more evident. So then our catchment scale research, so Rachel touched on this. Rachel's done a lot of focus work in the Upper Bann catchment. We also have done a lot of work in the Blackwater catchment. So the Blackwater catchment is a cross-border catchment in Tyrone, Armagh and into Monaghan. So these cross-border catchments are very, very important because of that cross-border management of waterways which are running from Northern Ireland and the Republic of Ireland. Obviously, how we manage a shared water resource like that is very important. How farmers, both sides of the border, are managing their soils, what nutrient recommendations they're getting. There's slight differences between Northern Ireland and the Republic of Ireland in terms of recommendations. So it's trying to manage that in a catchment system. We've done a lot of work in those cross-border areas with partners from the south. And a big bit of work we've recently completed in the Blackwater catchment, we're looking at changes to fertiliser recommendations. So while a lot of fertiliser recommendations are targeted to the more intensive farmer, a lot of Northern Ireland is actually managed more extensively. So those extensive farmers are maybe 1 or 2 cuts a year. Possibly it's due to wet soils. They can't cut the fields as often. There may be more part-time farmers, but there's a lower intensity of management there. So we are looking at what nutrient recommendations does a more extensive farmer need. Obviously, if they're doing less cuts of silage, they need less nitrogen. They also need less phosphorus, less potassium. So it was to get specific recommendations for those farmers who are managing less intensively. They don't need the big yields of grass. It was just so we needed to get more specific recommendations for those lower intensity farmers. So by working in the Blackwater catchment, specifically with a group of farmers there, we lowered fertiliser use by 42% for phosphorus. And these recommendations then, that work we did on more extensive farms fed into the Nutrients Action Programme for 2019 to 2022. So a lot of the research we do in AFBI feeds into the policy. So those future policy recommendations, we would do the research behind a lot of those recommendations. And the aim here is to try and help improve that water quality in catchments across Northern Ireland. And also as a big saving for farmers, a lot of the farmers like that one-to-one advice, nutrient management plans for their farms, so they saved on any unnecessary fertiliser. So soil monitoring is extremely important. It's really important that we do this farm level research. And as we were talking about pH there, it's how we are measuring our soils has been discussed very widely across Europe, and we know we need a standardisation of methods. So we know that countries measure nutrients in different ways. There's different methods how we measure carbon in soils. So this is known. And we've recently just published a paper on this through the EJP Soil project. So EJP Soil has 26 partners across Europe, which AFBI are the UK partner. And we were looking at how different countries analyse their soils, how do they get fertiliser recommendations, and we saw huge differences between countries, and it is known that there's huge differences, but how do we harmonise that? This is the question. So going forward, there's this discussion, how do we harmonise these methods so we don't have differences in pH recommendations between neighbouring countries? I mean, it's madness. And why do we have two different soil phosphorus tests? Why do we have, can we harmonise what we're doing across, particularly between neighbouring countries where there is a similar environment, similar, policy pressures? We need to kind of look at how we're doing things and try and standardise some of our methods. So that EJP project is a big European project on agricultural soil management, and it's aimed at addressing some of those key challenges, including climate change and future food. And it's about building collaboration between countries, so we're strengthening the research effort. So through that EJP soil project, we've had advantage of them moving down to subfield scale. So now we know that there's an awful lot going on at a subfield scale. So your soil is not even across a field. There are a lot of differences even at a field scale. So we've been doing some work looking at different technologies now where you can scan fields. So this is a project where we're looking at conductivity across a field, and there's 5 different European countries involved in this. By looking at the conductivity of the soil, we can get an idea of changes in soil texture across the field, the clay content, and actually fields are highly variable in texture. So this is a field in Tunbridge here, that's the River Bann, and it'll give us an idea how nutrients are moving through a field and how we can improve management at a field scale. And so we know that as well as soil texture and soil properties vary across a field, we know that nutrients are also highly variable. So this is a map of phosphorus at a field scale. So normally whenever we sample soils, we just get one bulk sample. So you'll only get an average nutrient content of a whole field. Well, actually a field is like this. This particular field here, this was in the Blackwater, is going from an index of 0 to an index of 4 in the same field. And this is really, really common. We've looked at a load of fields like this, and they're all showing a gradient of nutrients across the field. And it could be topography if it's a very sloping field, or it could be the way the farmers are applying the nutrients. Sometimes there's more particular concentration of slurry spreading or overlap of slurry or fertiliser in a particular corner of a field, accidentally usually, but it gets this gradient of nutrients across the field, and we know that this is very, very common, and now the technology is available for variable rate fertiliser applications, so we could manage this, so you could put fertiliser where it is needed and avoid areas where there's high spots of nutrients and reducing that hot spot of nutrients developing within a single field. We also know that grass yield varies. So grass yield can And arable fields are the same. You can get a yield variability of grass of 2 to 4 tonne a hectare across a single field. We've done a big DARE-funded silage check project. We've just finished it, where we're mapping a number of fields across Northern Ireland, and we found huge variability across single fields with lower and higher yielding areas. And now there's technology available, such as GPS on tractors, that can help farmers improve that nutrient application. So, and we know that there are quite a few farmers now investing in this technology, variable rate slurry and fertiliser spreaders. They have GPS systems now on tractors where farmers can have a yield map or a map of their nutrients across a field, and they can drive across the field and give a more even application of nutrients. And this always also helps soil health, because if we're avoiding those repeated passes of one part of a field, it'll help avoid soil compaction. Another area that we're looking at going forward is alternative fertiliser sources. So we know that chemical fertiliser, there's a huge carbon footprint of producing fertiliser and spreading it, particularly nitrogen fertiliser. And we know that we need to reduce our reliance on chemical fertiliser because of the amount of greenhouse gases produced. We're trying to look at recycling nutrients on farms, making more use of organic sources. There's a lot of companies now making pelletised products. So we have a big project at Ballywalter where we're looking at different alternative fertiliser sources, so poultry pellets, biochar, a number of digestate. So Lisa and Paul will talk more about that later on. But these are really important going forward, particularly things like compost and things are becoming more common. So we're doing the research behind these to see how good a nutrient source they are, what impact they have on soil health. So just to sum up then, I've covered a lot of things there. So nutrient management is integral to soil health. So at a regional scale, your dominant soil health indicators and broad drivers of soil health become apparent. So your climate, your geology, and your topography. So at the catchment scale, we're more focused on improving water quality and reducing nutrient hotspots. And then at farm level, we're looking at farm nutrient balances, and we know now there's a lot happening at a subfield scale that we can now manage because of improvements in technology. So going forward, we're going to be looking at trying more at that subfield scale level, and we're also doing more work on alternative fertiliser sources to reduce our reliance on chemical fertilisers.
Thank you, Suzanne. We're grossly running over time, but is there any couple of quick questions for Suzanne? Yes, please. Just maybe take the microphone if that's okay.
Hi, Claire Hempsey, DARA. Your farm scale map, or your subfield map of P, where you went from 4 to 0, have you overlaid that with runoff risk to have a look? Because if you're putting lots of phosphorus where it's 0 and 1, where it's needed, but if that's where the runoff risk is, that's maybe why it's lower, because a lot of P's got runoff in that area. Is that being considered?
That's what we're looking at. We're going to be currently looking at. I don't have any data on that, but that's the next stage. So now we've got the nutrient distribution. We're going to look at, because it doesn't mean that there's a runoff risk. It depends on the slope of the field and things like that. So it doesn't necessarily mean that there's going to be runoff. It just every field will be individual, but we're going to be looking at risk.
As long as it's being looked at.
Yes.
Lovely, thank you.
Okay. Suzanne, you're going to get off light because we need to move on. So, of course, Suzanne and Rachel and everybody will be available over lunch. So to move on, I'm really delighted now to invite some of our speakers, which are partners, partner with us on our research programme, and delighted to invite Dr. Marcellus Galdos from Rothamsted Research Institute. And Marcella is a soil carbon specialist, very experienced researcher in the areas of soil health and climate-smart agriculture, using crop, soil, climate monitoring and modelling to assess the impact of land use and agriculture management practices on crop yields, soil organic matter, soil moisture. And Marcellus, you're also, he's Oxford Farming Conference Emerging Leader, so that's very prestigious, congratulations. And you also chair the South East England Soil Discussion Group with the British Soil Science Society. So say that whenever you've got a couple of drinks in. But Michelle, thank you very much for being here today, and we really look forward to what you're going to tell us about carbon and soil health. Thank you.
All right, thank you. And it's a pleasure to be here. Thanks for the invitation. And I actually learned a lot already kind of this morning. It's my first time in Northern Ireland. And well, basically I'm a soil scientist. So obviously all the topics that are being discussed here are quite relevant for what I do. I'll be talking a bit about carbon within, kind of soil health as a proxy for soil health, but thinking broadly about soil health and climate. So climate impacts or how agriculture influences climate. There's my contact information there. So I'm at Rothamsted Research. Most of you probably are familiar with the institute. I'm based in Harpenden, near London, but I interact quite a bit with Northwick, the Northwick Farm Platform, really in southwestern England as well. So, basically as context, I think agriculture is really crucial to the discussion of the climate crisis because it's both impacted by and influences or affects the climate, right? So we have heard about runoff losses. So we know about, climate variability, extreme events will be really essential to understand them, to deal with them properly, to adapt. So climate adaptation is really crucial there. We also know temperature effects. CO2 concentration in the air is changing, and so on has an impact on plants, sometimes beneficial even. So we need to understand that. But also we know that we have a role in agriculture to help mitigate climate change, right? So both reducing emissions through inputs, so fertilizer application, livestock production, but also one of the probably only sectors that can do something about removing CO2 from the atmosphere at scale, right? Through sequestration of carbon in soils, but also, as we heard, really important to involve more broadly, holistically, nutrients in the discussion. So carbon can't be looked at on its own. We need to look at phosphorus, nitrogen, micronutrients as well, and nutrient cycling efficiency in systems. So losing less kind of nutrients to the environment and keeping that in crops and livestock. And we know things are changing locally, regionally. So when we talk about climate change and global warming and so on, we do need to start thinking about regional effects and how does that impact us where we are. So this is a really interesting website that you can actually explore regionally temperature changes, in this case, compared to an average of 1971 to 2000, and looking at what's the trend, what's happening. And now we can really think about how would changes in temperature that drastic affect soil health, in which ways, right? So what would that matter? Obviously, as well, as I've already mentioned, precipitation. So several models, and this is some work I did as a Met Office academic fellow. We looked at projections into future climate projections or current compared to future, and in precipitation erosivity. So the energy, the time, the duration, the amount of precipitation that falls in a particular period, and how can that influence erosion losses? So that's the universal soil loss equation there on the right. So we know there are several factors affecting, but one of them is the erosivity of rainfall. So in all of the scenarios and approaches, when we look at high emission scenarios, there's an increase in erosivity. And we can kind of zoom into Northern Ireland there, and you can see kind of the changes in colors. Even when in the medium kind of rainfall, they might become more erosive. So the high erosivity is expected to occur. And what kind of impact would that have on phosphorus losses that we heard about, sediment transport, nitrate losses and so on, even, soil health in general. So, so when we talk about climate smart, it's a concept that was brought forth by the Food and Agriculture Organization. We're really talking about, how do we reduce emissions, but also increase sinks of carbon, so both in trees, in biomass, in crops, in soils, and so on. But how do we adapt? So it's not a matter of, 50 years from now or 100 years from now. So farmers are faced with the challenge of really adapting to higher incidence of extreme events, and but also gradual changes in that affects when you sow, when you harvest, when you go into the field for operations. It affects livestock health, so temperature, humidity index, for example. So many ways in which we need to adapt now. So there's need for really a new agronomy, new extension, focusing on that. But also, we shouldn't forget at any time that farming, agriculture is really key, for basically productivity, incomes, livelihoods, right? So the human aspect shouldn't be forgotten. So that's what I like about this concept, which doesn't only focus on environment, but also brings in how do we feed people, how do we have livelihoods for farmers, be sustainable as well, economically, socially. And when we talk about soil carbon, which is my specialty at Rothamsted, so I'm the soil carbon lead, but it's not only important for increasing carbon sequestration in soils or reducing CO2 emissions to the atmosphere. When we increase soil carbon on a field, and that's really interesting, the survey that you're doing here, probably unique in the world, I agree. Be really interesting if you can follow up or try to understand what changes in the future, right? So that's a baseline, but can you increase or reduce losses over time? Because that's not only important for climate mitigation, but it's really crucial for nutrient dynamic cycling. So how do we actually have nutrients in the soil available for plants? Organic matter, or carbon specifically, is crucial for that, specifically in certain soils, so even sometimes more important than texture. So in highly weathered soils, not the case here, but obviously globally that's very important. It's sometimes more important than clay percent when we talk about cation exchange capacity, so much soils can actually retain and make nutrients available for plants. But also we know it's very, closely related to soil moisture dynamics. So how do you retain moisture for crops, but also root growth. So carbon influences how roots can actually explore the soil for nutrients and water. So this component of not only environmental implications, but also productivity and yield implications. So soil health, directly related to crop health, livestock health as well. So there are many challenges, obviously, to monitoring soil health, and I just listed some focused on carbon or soil organic carbon. They're applicable to soil health more broadly. But those properties, carbon included, they don't change overnight usually, right? So some properties really take years to change, even, to lose and to gain. Sometimes faster to lose than to gain, but also varies spatially. And it's really interesting, the work that you're doing here at different scales. I think that was a good segue also to what I'll be talking about. So you need to think about changes in soil, topography, climate, microclimate, so because it changes spatially. So you can't just say, give one number for a large region and say, this is your carbon stocks. But also they're costly and labor intensive, right? So if you I won't ask how much this program costed, but I imagine quite a lot. And that's, you have all the trade-offs, right? So I imagine it would be ideal to sample it at a deeper layer, but you can't do that in a robust way with the massive amount of samples that you're taking. So it's really interesting how you're covering a massive area and gaining information and knowledge about it. But also, climate change will impact carbon, right? So what's happening now won't be the same as 5 years or 10 years or 15 years or 20 years from now. So it also has that feedback loop. So higher temperatures, higher likelihood of extreme events will influence the potential to maintain soil health. So that needs to be taken into account. And one way to do it is really to combine different methods, different approaches. So all the way from going out into the field and measuring, that's crucial. Never believe someone who tells you that a model can give you all the information that you need, right? So you need to go out into the field and measure and sample into the lab, develop long-term experiments. So that's another crucial element. But also this was mentioned now, we have a plethora of new technologies coming on board to agriculture. So we have different sensing capabilities, all the way from earth observation, proximal sensing, sensors to scan soils in the precision agriculture kind of approach. But also, I'm a modeler, so I should also bring that up. They are really interesting tools when based on measurements to estimate what-if scenarios. So what if I change my management in this region, in this soil, in this climate? What are my options? What are, what could happen to yields, to carbon stocks, to nutrient dynamics if I change management or if I maintain this baseline? But also, climate is changing, so I can input that data into models. So that's probably one of the only ways to look at long-term changes, potential changes from climate as well. And this link between what happened before and what might happen in the future, I think it's really kind of illustrated in what can be done through long-term experiments. So you might be familiar with Broadbach, the longest running agricultural experiment in the world, based in Rothamsted research. That was the beginning kind of development of superphosphate and fertilizer application. And we're celebrating 180 years of continuous measurements this year. So that's fantastic, I think. And I also listed there a new long-term experiment that was developed kind of thinking about the challenges now that farmers have now as opposed to 180 years ago, which also involve how do tillage systems or how the organic amendments and crop rotations influence. Now, that when combined to projections, to models, and when based on that, that's really powerful. So looking back into long-term experience, learning from them, and then using that information to gather knowledge about what might happen. So this is an example on soil carbon measurements over many years, and there's a photo there for, during the World War, sampling soils. So, and then showing carbon stocks when large amounts of farmyard manure are applied over time. So that's kind of looking at the potential sequestration of soil carbon. It's probably one of the only places where you can look at what happened for 180 years when you add manure in large quantities, but also when you fertilize nitrogen, phosphorus, potassium fertilization, combining that. So that's the Broadbach experiment that was used to develop one of the kind of widely used soil carbon models in Rothsea. So that is actually a really interesting application. So learning from that specifically, you can actually develop a better understanding of how soil organic matter behaves in different climates and soil types and so on. And this is the other long-term experiment that I mentioned, kind of thinking about more regenerative agriculture, so sustainable agricultural practices. So what happens when you expand the diversity of crops? This is arable, focused on arable. So 3 or 2 or 4 or 6 crops tillage, minimum tillage compared to conventional, organic amendments and no organic amendments, integrated pest management. So this was set up in 2017, and it's supposed, obviously we hope it will continue for many years. So that's a new long-term experiment. But also looking at different scales. So some of the tools that I mentioned that are available to us in terms of research, and some of them are going out into the field, so they might be available, for farmers in the future. But for example, X-ray CT, so computer tomography, so taking X-rays of soils and looking at what happens over 30 years if you have no-till compared to conventional tillage, to soil pores. And not just to number or shape or size, but to connectivity of soil pores. And what does that, how does that influence soil moisture dynamics, nutrients, greenhouse gas fluxes, and so on, and root development. And on the right, actually scanning roots, so that we have that capability now, so far in the lab, but to scan plant roots and understand the differences, for example, forage grasses, such as Congo grass and maize, and look at and count, do a quantitative analysis of very, very fine roots, and understand, imagine the difference that it can have on soil carbon inputs over time, right? So that's really interesting potential application, kind of more on the research side. Now, moving a bit more to the field and technology that's becoming more available to farmers, spectroscopy. So imagine the cost of doing loss on ignition over hundreds of thousands of samples. Imagine with the advances of soil spectroscopy, it can complement potentially wet chemistry. And basically, through really kind of well-calibrated libraries, spectral libraries, you shine a light on a soil sample, and you understand, and you use obviously statistics, machine learning, and so on, and you have specific properties, physical, chemical properties primarily, that you can derive from that spectral curve. So when combined with wet chemistry, with really conventional lab, that can really expand the capabilities of soil sampling and analysis. So, and that's moving out into the field as well. There's spectrometers that you can take to the field and scan soils in the field. We have co-developed one on near-infrared side of the spectra. There's also mid-infrared. As I think was mentioned already, electric conductivity scanners. So that's a field, a long-term experiment, Rotham said, just scanned for electric conductivity, again, linking to texture and to management. Gamma spectroscopy, also using isotopes, so a series of new technologies. Really interesting new applications on sensing and sometimes proximal sensing, such as drones. So new sensors that you can put on drones and to really look at spatial variability over a field. So that's some work that was developed at Rothamsted, comparing in the Hoosfield long-term experiment, soil carbon on the surface, bare soil, when on the left actually measured by plot. So there's really a big contrast in different treatments over 100 years. And then on the right, what you can derive just from the actual data that you get from a multispectral sensor on a drone, combined with covariates as well. So it's really interesting potential applications now on that. Some work that we've done at the Northwick Farm Platform, which is really kind of farm-scale experimental area, 300 hectares of permanent pastures, improved pastures, and one section was converted to arable near Devon, near Oakhampton. And then what we did was use the gridded sampling that has been done over the years, and then bring in remote sense data from satellites, basically Landsat satellites, data, and terrain attributes, digital elevation model, and so on, and derive indices and then estimate soil carbon through that. Finally, some new approaches using process-based modeling. So a model that simulates the crop growth, simulates soil organic matter dynamics, simulates soil moisture dynamics, and fluxes. This is the Descent model. This is a farm in Newcastle, the University of Newcastle experimental farm looking at organic and conventional dairy production. So one half is organic, the other half is conventional, and running different scenarios, grazing, not grazing, adding organic amendments, not adding, and understanding the differences in carbon stocks over time with climate change. So that's kind of the link, the interesting application of models. Another project with the UK Climate Resilience Program, funded by the Met Office as well. I was still at the University of Leeds. I was a professor at the University of Leeds until about a year and a half ago. And this is with outdoor pigs, and we applied those models just with the baseline scenario, which is outdoor pigs for 2 years, followed by wheat production for another 2, and then 2 years of outdoor pigs. And what we could see, if the system continues like that, there's potential losses of carbon. And we don't have time now to discuss the reasons, but some of them are really the disturbance that the pigs have over that extended period of time, no biomass there, bare soil. So that's not really sustainable, system. So what we did there was, what if we change that? We include grass lays. We shorten the time that the pigs are out there. We include other crops and so on. What's the potential carbon stocks? So then in that scenario, you're not losing carbon anymore. You're not gaining much, but at least you're not losing. And also nutrients, so nitrogen dynamics. So the pigs are out there, soil is bare, there's urine and dung, so there's nitrogen going into the system. This is a nitrate vulnerable zone, actually. So that's really, if you don't have any crops to absorb that, there's a potential vulnerability. And we model that. So those are the, at the bottom, the model nitrogen, total nitrogen content, and then when you have pigs and when you don't, so bare soils. And finally, just to give an example of a current collaboration that we have with AFBI through Jonathan Holland. So we're running the Rothsea model over, as part of this Carbosec, part of EJP soil, and over several sites. And then we'll upscale that using remote sensing data. So have better estimates of soil carbon stocks regionally as well. One last example is the soil carbon clay ratio. That's an interesting way to look at what's the potential for sequestration of soils. You can't really store carbon forever everywhere, right? So it's very different. So in this case, we use the National Soil Inventory over 2 periods of time, up to 83 and then 2003, and look at the difference as well. And developed, so colleagues of mine developed this index of carbon over clay. So that kind of indicates how much carbon you can actually store depending on clay content, and that's already published, and you can look at differences. There's several things we could talk about, but just to be brief, there's differences overall in different systems, land uses, arable, lake grass, permanent grass, losing carbon over time between the two inventories, right? So that's one thing. The other thing, yes, the only land use that gained some carbon was woodland, but also there's kind of up to 45% of soil, arable soils of land would be considered degraded in England and Wales. But there might be minimum kind of realistic targets for increasing carbon over specific textures. So to end, yes, we know that climate-smart soil management, so when we talk about climate-smart agriculture, we can apply that specifically to soil health, to carbon. So you can increase carbon sinks, reduce emissions, build resilience to extreme events, but it's not all yeah, in a perfect world, you have all of those, but there are trade-offs and caveats, right? On sometimes you increase carbon here, and you might reduce or increase emissions. So, anyways, it needs to be seen as a system, and those indicators vary in space and time. So, again, you can't bundle everything into a land use or a management system. You do need to think about specific aspects. So it's really interesting to explore the combination of all those. So long-term experiments, the on-farm observations, such as the survey you're doing, sensors and modeling. And finally, we do need to think about locally, regionally and locally appropriate solutions, right? So when we have the information, the data, the models, we can zoom into specific climate, soil management combinations and provide solutions. That's what I had. Thank you.
Thank you very much, Marcellus, and really fascinating to see so many technologies coming forward now for soil carbon content. Any questions? Yes.
I'm glad enough anyway. I think I was kind of done from the National Trust, and I just wanted to pick up on a point that you sort of highlighted around soil carbon saturation. Do you feel that we really understand enough about soils to be able to know the potential? Because a lot of scientists out there are kind of downplaying the role that farming can play, and AFBI themselves actually have quite long-term research in Northern Ireland to show that we've not hit the saturation point. So as an expert in this field, I just wondered your thoughts on that one. Thank you.
Sure. Yes, if you remember the figure from Rothamsted, the broad-bottom experiment, if you use the IPCC kind of default, 20-year period for saturation, that would be completely off, right? So you notice it's still increasing. After 100 years, it was still increasing. And yes, so we're trying to learn more about it. One way to do it is look at fractions. It's like, where is carbon located in soils and how is it associated with minerals? So there might be a strict limit to how much carbon can be stored in the mineral-associated organic matter carbon, for example. There might be a bit more flexible on particulate organic matter carbon, which is derived from plant materials, so that you could. So we need to treat them differently. Yes, so we're learning about that. There's a lot of research on that, and the clay carbon kind of ratios is one approach, but that doesn't work, for example, for different soil types, or it might need to be adjusted as well. So yes, that's a good point.
Any other questions? No? Well, Marcelo, you're here over lunchtime anyway, and thank you so much. Really interesting. So next up, and before your lunch, John, you stand between us and lunch, but I'd really like to welcome John Williams to the stage now. John is head of the EDAS Soils and Nutrients Group. You've been a scientist for over 30 years now, John, and I know you work extensively with a lot of farmers across England, so thank you very much, and over to you.
Thank you very much. I'm also a Welsh rugby supporter who spent an awful lot of time shouting at the telly over the last month, so apologies for the somewhat husky presentation style. Organic materials, don't you just love them? They're fantastic. There's an awful lot of them around in the UK. Around about 80 million tonnes thereabouts of livestock manures, around about 3.5 million tonnes of biosolids, million tonnes of compost, more and more anaerobic digestate from the food, anaerobic digestion of food waste and all the rest of it being applied to land now. So there's around about 92 million tonnes. Wow. If I'm a policy maker, that's a very big amount of manure to deal with and a big policy headache. If I'm a farmer, it's a fantastic resource of nutrients and organic matter. And I always struggle to figure out what would 90 million tonnes look like. Now, as an Evertonian, it's fair to say that the performances on the hallowed pitch of Goodison Park haven't been particularly good at the moment, and an alternative use for that pitch might be a manure store. So I kind of worked out, roughly, what 90 million tonnes would look like if it was piled on the hallowed turf of Goodison Park, and it ended up being around about 11,000 metres tall, which is the equivalent of 1.3 Mount Everests. So as I say, from a policy perspective, wow, that's a big headache. From a farming perspective, let's use those nutrients, let's use that organic matter. And this slide kind of gives you an indication of the value of these organic materials, typical application rates there for cattle FOM, slurry, poultry manure, digestate and biosolids. And you see there crop available nitrogen supply from those different materials. And, you know, poultry manure, only 8 tonnes per hectare of poultry manure applied in the spring is giving us around about 90 kilograms per hectare of crop available nitrogen. So that's the nitrogen that the crop can actually see and utilise. And, you know, looking at some of the other nutrients that we're getting there, the cattle FOM is giving us around about 100 kilograms per hectare of phosphate, around 370 kilograms per hectare of potash. And if you look at the financial value there, it starts to add up a little bit. And this is even using the latest fertiliser prices of around about £1 a kilogram for nitrogen, £1 a kilogram for phosphate, and about 70 pence a kilogram for potash. This time last year, these values would be double that. So it just gives you an indication of the value of these materials, particularly when we're looking at high costs of fertiliser that we were looking at 2 or 3 years ago. Really useful nutrient sources and really good way of saving money on fertiliser inputs if they're used efficiently, as Suzanne was mentioning earlier. And it is at times like these that I'm really glad that I'm not a policy maker, because managing organic materials is a bit of a nightmare, it's fair to say. We're applying nitrogen to the soil. We've got the organic nitrogen, which is, you know, there is likely to go into the soil organic matter and mineralise over time and become available, probably a little bit unpredictably. But within a few hours of application, we're spreading the manure, and what we're seeing is ammonia going up in the atmosphere. And that tends to happen very quickly. After application, and ammonia is a very important pollutant for all kinds of reasons. If the nitrogen, the ammonium nitrogen that's remaining in the soil after volatilisation will be subject to nitrification, and obviously that will convert it to nitrate. But we also see nitrous oxide emissions being given off, and if we've got lots of nitrogen in the soil, then we end up with a lot of nitrous oxide going off, and nitrous oxide is bad news because it's a greenhouse gas. 300 times more polluting than carbon dioxide, so we've got to worry about that. Where we've got, do you have any wet soils over here? Potentially. Being from North Wales, it's lovely to come and see the green grass and hear the rain this morning. That makes me feel very much at home. But we end up with quite a lot of nitrogen gas going off as a result of denitrification, which again causes nitrous oxide emissions. And then we mentioned nitrate. We mentioned about nitrate already. If we've got a lot of nitrate in the soil, particularly at the end of the harvest period in autumn, just as the soils are wetting up and we end up with this lovely rain that we're having, then that nitrate's going to wash out of the soil, because nitrate just isn't held in the soil in any way, shape or form. It's a nitrate. It's a negatively charged ion. Wash it out the way. Wow. Get that information across to farmers as a simple way of minimising pollution. It's really, really tricky. But ultimately, if we come up with systems which maximise the crop availability of the nitrogen, we end up getting as much as that nitrogen into the crop as we can. Everybody's happy. Farmers happy, we're reducing fertiliser inputs. Policy people are happy because we're minimising, we're not wiping out, but we're minimising the losses to the environment. And standing here, it's relatively straightforward to manage the nutrients in manures. All we've got to do is know what's in them, minimise the losses, come up with practices that can minimise the nitrogen losses in particular. We've then got to figure out how much of that nitrogen is going to be available to the crop so we can cut bag fertiliser, spreading it accurately and evenly. Sounds straightforward, but can be a big, big challenge. And then account for those nutrients when you're doing your nutrient management plans, which are obviously very, very positive at the moment over here in Northern Ireland. So it's fair to, knowing the nutrient content, fair to say they don't come in bags of 20-10-10 on the side or anything like that. So you've got to be really understanding the factors that are likely to affect the nutrient content of manures. And clearly livestock type has a big impact, and the diet has a big impact. What goes in the front end certainly influences what comes out of the back end in terms of the nitrogen, the phosphorus and the like. And obviously if we're using concentrates, lots of concentrates, then the nutrient content of the manure is going to be a lot higher than if we're using less concentrated feeds. Clearly, if we're using bedding, if we're using straw, if we're using sawdust, that will have an impact on the nutrient content and the amount that we're using. Water use and also water ingress into slurry stores. There's a heck of a lot of water goes into slurry stores, and you know the nutrient content of a slurry store, or the concentration of nutrients in the slurry at the end of August would be a heck of a lot different, a lot higher, I'm guessing, than after the rain we've had in September and October, just because of the amount of rainfall that gets into the slurry store, the amount of rainfall that runs off the concrete yard and all the rest of it. So anything we can do to minimise that water getting into the slurry store is a good thing, both in terms of maximising nutrient content, minimising the spreading costs, but also reducing the need for slurry storage capacity. Now, we are very lucky in this country. We have these very good decision support tools out there and guidance for farmers on how to best use nutrients, and AHDB's Nutrient Management Guide, I suggest, is a really good place to start if you're looking at using manures. They've got these typical figures for the nutrient content based on different livestock categories, different manure types and the like, particularly based on the dry matter content of the slurries and all the rest of it, just to demonstrate how the impact of different dry matter contents, water contents have on the materials. And it's a comprehensive guide. But as always, anything that is an average, is an indicator, is only going to be an average, and there's a lot of variation across that average. And so taking samples and getting the manure analysed and sending it off to a lab, really, really important in terms of being able to quantify what the nutrient content of the manures are on your farm, what the nutrient content of the digestate is from that food-based digestate plant, because it might be the feedstock one year is very different to what the feedstock is the other, all the rest of it. And analysing for dry matter, nitrogen, ammonium N, total pK, magnesium and sulphur, really, really important, the macronutrients that we use. And poultry manure, anyone who's using poultry manure, analyse for uric acid N, because that's a part of the ammonium N in poultry manure, which is very, very important to assess. And taking samples, representative samples of manure, is really, really important, because if you take crap samples, you'll get crap results, basically. And there's good guidance in the Nutrient Management Guide as to how to take the samples to make sure that you end up with a very representative sample of what's being spread to land, and that is always a challenge. And this graph kind of gives you a feel for the variation in typical values for manures. This is the relationship between dry matter and total nitrogen that we use to derive the typical values for total N in RB209. And you can see the average dry matter is around about 6% dry matter, and the figure there would be 2.6 kilograms of nitrogen per cubic metre. Not a bad average, but you can see the variation in that average. It goes from around about 1.2 up to around about 4.5. And that's the influence of the diet, etc., and the way the manures are managed in terms of the variation in the nutrients there. So, we know how much nitrogen we're applying. How much actually gets to the crop? Because clearly, most of the readily available N, if it's not lost by leaching, volatilization or denitrification, should be available to the crop. But we've also got this organic stuff as well, this organic material in the manures, which will mineralize over time, and we have to account for that in order to come up with a crop available nitrogen. But fundamentally, if we minimize the losses, as I said before, we'll maximize the crop available N. So thinking about the manure management practices that we use when we apply the materials, really, really important. And if you haven't got the message yet, all manures are different, particularly in the terms of the nitrogen supply that they provide. Solid-based manures, particularly cattle FYM, probably around about 3/4 to 80% of the nitrogen is in that organic form. It's in the lumpy stuff, which is only going to break down over time. It's only going to mineralize over time. And how that mineralizes will depend on soil conditions, temperature, rain, moisture content, and all the rest of it, because ultimately it's the bugs, it's the soil microbes, it's the soil bugs that break down that organic matter to produce the mineral nitrogen. Cattle slurry, around about 40% is in the readily available form, the ammonium N form, which potentially is available to the crop. Poultry manure, as said before, about 40% in the readily available form, 60% in the organic form. Digestate, food-based digestate, rocket fuel, basically, a lot of the time. You think about what's going in the feedstock, you've got blood, guts, pies, you name it, high nitrogen source materials in there, and around about 80 to 90% of that nitrogen is in the available form. So all of a sudden you're thinking, hang on a minute, that could be quite pokey, that. Not both both in terms of the crop available nutrient supply, but also the potential risk to the environment. And biosolids, I guess there's not a lot of biosolids spread in Northern Ireland as far as I understand, but basically a lot of that as well is in the organic form and only really a low readily available end material. Some work that was done a few years ago now, but reported in 2016, which we carried out to look and see what the impact of how much of the organic nitrogen from the different manures mineralised over time. And this is work reported by Anne Bogal, a colleague of mine. You can see it kind of fell into two packs. The pig slurry and layer manure, the mineralisation rate of that organic matter was a lot greater than from the cattle FYM and the pig FYM, the cattle slurry. And that probably is probably a reflection of the diet and the amount of fibre that's in the manure, and certainly of the FYM for the amount of straw that's in the manure as well is likely to break down quicker, whereas the pig slurry and the layer manure, the organic nitrogen there is likely to mineralise a lot quicker. Okay. So, I've mentioned about nitrate leaching losses and minimise nitrate leaching losses. Dead easy. Dead easy. Don't put it on the autumn, he says here, laughing. Basically, if you're putting manures onto soils before crops which don't have a nitrogen requirement, and they're high readily available end manures, the slurries, the poultry manures and the like, crops generally, certainly cereal crops, these are data which were collected from experiments which were carried out on winter cereals over around about 3 harvest seasons from around about 4 sites in England about 20 years ago now. But effectively what we were seeing there was when we put these high readily available end materials on the slurries and the poultry manures, and we put them on in September, October, November, then there was not enough crop growth after the application to take up that nitrogen. And effectively the rainfall, the drainage, the effective rainfall after application was large enough to wash that nitrogen beyond rooting depth. So effectively the high readily available end manures were a high risk of nitrate leaching from the autumn application timings. When we got to December and January, there was less hydrologically effective rainfall, less drainage after application to wash that nitrogen beyond rooting depth. So the later you go, if you can predict what the weather's going to do, which is another issue, then the risk of nitrate leaching from these highly readily available end materials is a lot less, which, surprise, surprise, corresponds with a lot of the close spreading periods in MVZs. The losses from the farmyard manures, those manures which have lower readily available N contents, well, they're a lot lower because there's a lot less readily available N, so the risk is less. So straight away, you're able to manage the nutrients differently, or manure types differently. And that's all great until you come to these drained soils. And these soils where the drainage engineers did a cracking job in the 70s and 80s, draining the soil so as the water could get away nice and quickly, down the cracks and away into drains. Particularly if we had permeable fill above the drains, then there was rapid transfer of water from the top to the bottom. So in the springtime, generally, soils are a bit wetter than they are in the autumn. Certainly they are in England. In Wales, it's probably wet all the year round, and similarly here. But it makes the point how important it is the soil conditions are right when you're spreading the manures. And you've got to think about not just the nitrogen, but the phosphorus as well. And this is what we found when we were doing some work on hydrologically isolated plots over in England on a site with which was average rainfall, about 750 millimetres of rainfall in Oxfordshire on some very heavy soils, dentuous series soils, which needed to be drained in order for them to function from an agricultural perspective. And you can see here, we looked at different application timings and the impact on phosphorus concentrations in drainage water. And what we saw there was, for when we applied in the autumn, phosphorus concentrations were pretty low, certainly below 1 milligram per litre total dissolved phosphorus. And when we got to the spring application timing, where we were able to travel on these heavy soils with a big slurry tanker and all the rest of it, because it had dried out on the top well enough to hold the weight of the tanker, but underneath it was still wet. It's a bit like my mother-in-law's chocolate cake, it's sort of burnt on the top and it's all a bit hard, so it takes a while for the knife to get in, but once you get into the soggy bit underneath the burnt bit, then it goes down very quickly. Don't tell her I said that. And what we saw was, we went on 2 weeks, it was great, lovely sunny day. I remember being there, spreading it myself. Nice sunny day, 2 weeks later, it smashed it down with rain. What happened? Wham, phosphorus went out the drains. So, as a policy person, I'm interested in nitrogen. Yeah, put it on in the spring. As a policy person, I'm interested in looking after the phosphorus. Whoa, hold on a minute here. What are we doing? And, you know, basically, we didn't have to take the samples because that's what it looked like when it came out of the drains, Guinness and gin. You know, Guinness was where the slurry had gone on, gin was the control plot. So it's not easy, this manure management. So when people say you need more storage, that's why you need more storage, because ultimately you've got to spread the manure at the time that the soil conditions are right, as well as when the crops are likely to need them. And that means wider, narrower, a lot of the time, application windows, and probably wider times when you can't spread, which means you need the storage. Oh, so the water quality people are panicking already. Now let's get on to the air quality people. As I say, ammonia volatilisation, significant loss pathway. Agriculture is responsible for around about 90% of all the ammonia emissions that come from the UK, and it's bad news. I mean, basically it causes acid rain. What goes up comes down, so it deposits itself on sensitive habitats, which again, you know, causes all kinds of issues with nature recovery and all the rest of it. We're damaging ecosystems significantly. And also it's an impact on human health as well. It causes issues with respiratory problems, acts as a nucleus for these particulates, PM2.5, PM5, PM10. So there's a big policy impact looking at ammonia emissions. And you can see hopefully from that graph that, I mean, losses from manure application account for around about a quarter of all emissions from agriculture. So if we can sort those out, as well as from fertiliser applications, then we'd be doing a good job in terms of reducing our emissions. And it was really nice seeing photos of band spreaders on the, on the slides earlier, and this is crucial. Effectively using these low ammonia emission technologies has got to be the right way to go. The band spreaders, you've got the, let's see, top right, I think it is, you've got a training shoe there. You've got another training shoe, top left. On an umbilical system, they've got shallow injection and then a band spreader there. These sort of kit, expensive, heavier to use and all the rest of it, but really good from an ammonia emission perspective. We've got good data to back this up over several years of experimentation. I think one of the things to notice here is how quickly the ammonia goes off in the chart there. On the right, you can see there that we've got most of the emission happens within the sort of 5-6 hours period, and then it kind of flattens off, but all the way through, the dotted lines are below the solid line, and that shows that the band spreading, where we applied with a band spreader, reduces the ammonia emissions compared to surface broadcasting. And certainly once we use shallow injection equipment, that is a significant reduction. So this bit of kit is really important, not just from an ammonia abatement perspective, but also for reducing odour. Within grassland systems, if we're putting the slurry in a band underneath the grass, then that means there's less opportunity for rejection when we come into early grazing or something like that. And certainly, so again, it widens the spring application window because you're not contaminating the grass swales as well. So lots of benefits from that perspective. And so potentially, and it's not really affected by weather, you know, wind in that respect as well. So it increases the number of spreading days. And also from a nutrient management perspective, it spreads it nice and evenly across known bout widths, which is going to keep Suzanne happy. Estimating, because there's a lot going on there, how much has been lost by leaching, what's the impact on my soil type, how much has my rainfall been, how much ammonia volatilisation have I, oh my goodness. Well, again, luckily, we've got these decision support tools that help us. We've got the Manna MPK system, which is a wee bit creaky and a wee bit old now, it's fair to say, and doesn't fit. I can't get it on my smartphone. I mean, goodness, my children, how do they live without having Manna on their smartphones? I don't know. But anyway, it's all been used to create the tables in RB209, which give you different crop available nitrogen supplies from different application timings, but also application methods. And all that information is used in other decision support tools as well, such as the CAFRI nutrient management tool. So, all that about nitrogen. What about phosphate and potash? Well, it's great, because phosphate and potash doesn't tend to move very far, really, unless we get into silly indices and all the rest of it. So from an agronomic perspective, it's relatively straightforward, because nitrogen will go anywhere. Phosphorus tends to stick around. The issue with manures is that, by and large, when we spread manures, particularly solid manures, so poultry manures, FYM and the like, we supply more phosphate than the crop needs. And you can see this is an example If you were putting on 35 tonnes per hectare of pig manure, which is a reasonable dose, you'd probably get around about 25 kilograms per hectare of crop available nitrogen. I'm assuming we're at index 2 here, so the phosphate requirement is 50 kilograms per hectare because this is for winter oilseed rape. Potash is at 40. We're applying 210 kilograms per hectare of phosphate there and 280 kilograms per hectare of potash. So if I was to go back year on year on year to that same field, I'll be building those phosphate indices up. Probably not the best thing to do. And this is why we've talked about it already. Generally, there's quite a lot going on in this graph. I'm grateful for Paul Withers and the team for publishing it so I can use it. But basically what's happening here is it shows that on the winter wheat and the barley lines there, you can see that there's typically no response to phosphate once we get into index 2, which is around about between 16 and 25 milligrams per litre of Olsen P, okay? So there's no response to phosphate. So basically, if you're putting fertilizer on and you're index 2, all you really need to be doing is replacing what you're taking off, okay? Once you get up into the high sort of index 4s and index 5s, data from Rothamsted, the Broad Book experiment that was mentioned earlier, shows that effectively at that soil indices, you saturate the soil with phosphorus, effectively. And then any of the phosphorus which would normally be held into the soil on that soil type won't be held anymore because it can't take any more. And you end up with significant amounts of phosphate being leached out. So you don't want to get up to index 4 and 5 if you can possibly help it, because the risk of phosphate loss is greater. I mean, you're still applying nitrogen, which is good. You're still applying sulfur, which is good. You're still applying organic matter, which is great. You don't want to overcook the phosphate, basically. So having your soil analysis, brilliant, is absolutely superb, because ultimately you can then target where best to put your manures. And putting solid manures at index 4, wasting your time, really, a lot of the time. And, well, not necessarily wasting your time from a nitrogen and sulfur perspective, but the risk of losses to water will outweigh the benefits that you get from the nitrogen, potentially. Application rates, well, you know, basically, really, really important, because you can go through all that, and if you don't know how much you're spreading, then your nutrient management plan is going to be a waste of time, ultimately. So simple things, just by quantifying the forward speed and discharge rate of the material, spending money on particularly solid manure spreaders which spread the manures nice and evenly. You have these beaters at the back which smash it to bits and chuck it 24 metres, some of them will tell you, to spread it nice and evenly, that sort of thing. Really, really important. And, you know, particularly for solid manures where the bulk density varies massively, understanding how much is in the spreader is really important. Stuff that's fresh out of the shed could be all nice and fluffy and dry and all the rest of it and have a very low bulk density of about 0.6 or something like that. Stuff that's been stored on the side of the field could easily be bulk density 1, 1.2. You fill the level to the same, fill the spreader to the same level, and you've got completely different amounts in, just because the bulk density is different, just because of the way the material is. So just these little details about understanding what state the material is in has a big impact on understanding how best to use it. So, organic matter, lots of talk about organic matter. Well, surprise, surprise, manures have got lots of organic matter in them, and particularly the solid manures. Slurries, 5% dry matter, 95% water, not a lot of organic matter in water, but certainly cattle FYM, broiler, green compost, and these, you know, digested biosolids cake, significant amounts of organic matter in them. So at application rates, which would get close to the NVZ application limit, field application limit of 250 kilograms per hectare of total N, you're applying around about 5.5 tonnes per hectare of organic matter from cattle FYM, 5-ish from the compost, only around about 2.5 from the broiler litter, and that's again because 8 tonnes per hectare is all you're allowed to apply for the broiler litter because it's got tons of nitrogen in it already. So the application rate for poultry manures are low because of the nitrogen content. And this is some lovely data from the DC Agri project, which we did a few years ago, which we looked at the impact of digestate and compost use in agriculture and what it was like to have on soils and what the nutrient availability of these different materials were. And what we saw there, we had these long-term experiments again, where we'd applied these different materials for different amounts of time. And you can see where we've applied green compost for 9 years, we've seen an increase in organic matter the same as where we've applied FYM for 20 years. And effectively, we applied 50 tonnes per hectare, so we applied half the amount of organic matter in the green compost to see the same rise in organic matter than we have on the FYM. So something's going on here in terms of, you know, we seem to be able to build the organic matter a lot quicker with the compost than we are with FYM. And if we look at the effect on topsoil microbial biomass, you see where we've put the compost, it's gone up a little bit, but where we put the FYM, it's gone up a heck of a lot. So straight away you start thinking, what's going on here with the compost and what's going on with the FYM? Well, effectively, most of the available carbon, most of the sort of yummy sugars and yummy biscuits and all the rest of it that are in the compost will have been driven off by the composting process, and we're left with lignin, you know, recalcitrant organic material, which is more difficult to break down than compared to the FYM, which has got loads of sugars and polysaccharides, monosaccharides and all the rest of it in it, which are better food for the microbes. So you end up increasing the soil microbial activity where you put the FYM. And that's kind of reflected where we put the slurry as well. We've got higher microbial biomass where we put the slurries over 20 years as well. So not all organic manures are the same when it comes to their impact on soil biological properties. But also, it's really important to understand the benefits that applying organic materials have in these other soil properties, like increasing available water capacity. These are on light soils in England at Gleethorpe and at Harper Adams College. You can see there where we've put a lot of carbon, a lot of organic matter, a lot of organic manures, then we're increasing the available water capacity, which is great in drought years, reducing the bulk density, which demonstrates we've got a good impact on soil structure, much better structure. Porosity's there as well. We've got higher porosity, which again means the water can drain out, so the water can drain out better. It can be held onto better in terms of the available water capacity, and we're also reducing the penetration resistance, which again is an indicator of reductions in compaction. So organic matters are great from a soil quality perspective, but you've ultimately how and where you apply them is controlled by the nutrient content, and that's really important. Okay? So, message that you've heard already. Maximise the nutrient benefits to maximise the returns. So effectively, if you need to know how much the crop needs. If you don't know how much the crop needs, then that's got to be the baseline. So use the recommendation systems. Really important that you account for manure nutrients. You've got to know what's in them. You've got to know what the application rate is, and you've got to minimise the losses. The days of that tanker needs to go on these 3 fields in the next 2 days, because that's what the contractor says so. Nah, can't do that anymore. Storage capacity is crucial to allow applications when soil and climatic conditions are appropriate. You know, go on in the autumn. Yeah, okay, fine. What about the nitrate issues? Go on in the spring. What about the phosphate issues? Go when the soils allow you to go within those constraints, and ultimately that means having to have as much storage capacity as you can. Use nutrient management planning, and there's no question that organic manures are good sources of organic matter, but not all materials are the same. Okay, and it's lunchtime.
Thank you very much, John. Any questions for John? Or you can queue up in a queue with him at lunchtime. I'm really glad you started to introduce the soil biomass story, because I think that's what we'll be honing in on now after lunch, and trying to understand the links of that with carbon sequestration, etc. So, folks, it is lunchtime. Apologies, bad chairmanship for letting us run over so much, but it is lunchtime. I would ask maybe if we can attempt to come back for about 1:15. We'll catch up a little bit time and we'll still wrap up on time. Thank you very much, and lunch is in the foyer.